So I wanted to give you an introduction to the molecule shapes Phet. This is a great resource when you're trying to understand VSEPR, or what is valence, which stands for valence shell electron pair repulsion. And you'll want to go ahead and open up a tab and then put in Phet molecule shapes, or simply follow the link that I've given you in this video. When you click on the play, you get to this screen, which asks you for model or real molecules. We're going to do models. You'll get here. This is representing the balls represent atoms. The lines represent bonds. And you can click on one of the atoms and then drag that atom around. And notice that the other atom on the other side does what? Well, it moves away from it. That's right. And so no matter how fast you move it, the other one's going to move away. And that's due to the like charges of electrons, the fact that they're both, all valence electrons are negatively charged, and so they're going to repel each other. So that's why this is called valence shell electron pair repulsion, or VSEPR. And so here we have three atoms, and they are each of the two outer atoms are bonded to the central atom by a single bond. Now, what we want to do is go ahead and go over here and show bond angles. You can see when they are as far away from each other as possible, that's 180 degrees. You see it always settle back in there. Understanding that bonds are not rigid. They are not a physical, there's no physical thing there other than this this attraction force. And that makes a bond, and then it's the repelling of these negative charges of these electrons that are in these bonds that actually cause them to move away from each other and get on opposite sides of the central atom. Now, go down here and you'll click on molecule geometry and electron geometry. And you'll notice up here we have lone pairs and we have double bonds and triple bonds possible also. Now, if we have a central atom that has two single bonds on it and it has no lone pairs, then that atom's electron geometry is linear. The shape based on just where electrons are would be linear or a line. In this, because there's no lone pair, then that means the molecule geometry is the same, which in this case is linear. Now, that's if you only have two atoms bonded to the central atom. If the central atom had three atoms bonded to it, then it would look like this, and they would get as far away from possible from each other, which, as you see, turns out to be 120 degrees. All single bonds here, and no lone pairs. You don't see any lone pairs. You can turn it sideways and just look to make sure, but yep, no lone pairs. So we central atom with three atoms bonded and no lone pair, then that means that the electron geometry is trigonal planar. Or in other words, you see the triangle, 1, 2, 3. Here we see the triangle, and it's in a single plane. So if I turn it like this, you can see everything exists in this one plane. All right, so that's why it's called trigonal planar. It's just one plane. Okay, so that's if you have three atoms, no lone pair. The molecule shape, because there's no lone pair, is the same as the electron shape, which is trigonal planar. Now, if we have a central atom with four things bonded to it, that becomes four. You can see tetra, the prefix tetra for four, and a tetrahedron looks like this. And see if I can get it where it's a good visual for you. But you get the sense that these three atoms are now pushed away from this new atom that comes in on top. Now the angles are 109.5 degrees. That's as far away from possible as they can get. The electron geometry is tetrahedral. There's 4 different domains where their electrons are. 1, 2, 3, 4. And so these 4 domains are made up, in this case, of just 4 atoms. 2, 3, 4. And so the molecule shape is still the same name because it has no lone pair. All the atoms exist. Wherever there are atoms, that makes up the molecule shape. And so this is still a tetrahedral molecule shape. Now, this is where things then can begin to change. Now, there are exceptions, and there are some atoms that, central atoms, that can take more than 4 atoms or bonds, but we're just going to limit what we do here to just 4 bonds. And so the other options is that what if one of these domains, instead of having a atom bonded there, we're going to take the atom off, but instead put a lone pair there. And this is what the lone pairs look like on this simulation, which is really cool. But and so you can see the lone pair of electrons. They still are electrons there, so that means they still cause repulsion. And so the electron geometry, considering that there's electrons here, is still tetrahedron, still 4 different domains where there's electrons. There's this bond that has electrons, this bond, and then you have the lone pair up here. So there's 4 different ones. So still, the electron geometry is still tetrahedron, but the molecule shape is no longer tetrahedron because it doesn't have an atom up here. So where the lone pair, we ignore it and we just look at the shape of what's left. All right? And if you look at this shape, what does this look like? Well, it looks like a pyramid. You have a top with 3 legs coming out. And so with 3, that means it's a trigonal pyramid. If we take off the showing of the lone pairs, you see this is what it looks like, a trigonal pyramid. All right? Now, you can also have 2 lone pairs. So let's go back to showing the lone pairs. Let's remove another bond and put that second lone pair in. And now you have this shape. This shape, if we get rid of the lone pairs, you see, looks like it looks kind of like the linear, except it's bent. And that's why it's called simply bent. So a real simple name for the molecule shape is bent. Even though, if we show the lone pairs, even though we have 4 different areas with electrons, so the electron geometry is still tetrahedral. Okay? Now, we could also get rid of one of the lone pairs and get rid of the other lone pair. Let's go back to the trigonal pyramid. This is trigonal planar. Trigonal planar remember, had 3 different domains with electrons. What if one of these, though, had a lone pair? It would look like this. Again, what's that shape? Well, it looks just like the shape we just showed, which is a line that's been bent. And so the molecule shape is bent, even though with the lone pair it has 3. So you see that tri would be trigonal planar. All right. I hope this helps you out when you're doing the molecule shapes. It's a good visual for you. Another one just to show you that anytime you have 2 things bonded to each other, only 2 things bonded, doesn't matter if it's a single, double, or triple bond, it can only be in a line. There is nothing else other than linear for any 2 things that are bonded together. I hope that helps you out a lot, and I will be adding this to some of our other videos.